Physics part 222. So it's Nelson, rather double Nelson, 222, double Nelson. T is equal to 2 pi under root I over g, where g is the acceleration of the free fall. An experiment in which the period of the simple pendulum is measured can be used to determine the acceleration of free fall. The experiment is repeated for different lengths of the pendulum, and the gradient of the graph T2 against L is 4 pi square over g. This provides an alternative to the dynamic experiments in which the time for a body to fall through the measured distances is determined, and g is calculated from the equation of motion, as we have already explained in previous chapter. In our previous chapter, we've got an example for you. A helical spring is clamped at one end and hangs vertically. It extends by 10 centimeter. When a mass of 50 grams is hung from its free end, calculate A, the spring constant of the spring. B, calculate the period of small amplitude oscillations of the mass. Calculate A using K is equal to F over delta R. The spring constant K is equal to 550 into 10 power raised to minus 3, 9.8 into 10 power raised to 10 into 10 square, which is 4.9 newtons per meter. B, using T is equal to 2 pi under square m over k, the period T is equal to 2 pi under square 50 into 10 power raised to minus 3 divided by 4.9 is equal to 0.63 seconds. Now it's your turn. The acceleration of the free fall at Earth's surface is 9.8 meters per second. Calculate the length of a simple pendulum which would have a period of 1 second. The acceleration of free fall on Moon's surface, I beg your pardon again, 1.6 meters per second. Calculate the pendulum in A, its speed of oscillation on the Moon. We've got section summary for 10.2, 10.3 and 10.4. The period of an oscillation is the time taken to complete one oscillation. Frequency is the number of oscillations per unit time. Frequency f is related to period of t by the expression f is equal to 1 over t. The displacement of a particle is its distance from the equilibrium position. Amplitude is the maximum displacement. Simple harmonic motion, SHM, is defined as the motion of a particle about a fixed point such that its acceleration A is proportional to its displacement x from the fixed point and is directed towards the fixed point A x minus x, or A is equal to minus w square into x. The constant w in defining equation for simple harmonic motion is known as angular frequency. For a particle oscillating in SHM with frequency f, then w is equal to 2 pi f. Simple harmonic motion is described in terms of displacement x, amplitude x square, frequency of f, angular tendency, by the following relations. While displacement is x is equal to x0 sine w into t, or x is equal to x0 cos w into t. Velocity is v is equal to x0 w into cos w t, or v is equal to minus x0 w into sine w into t. Next we'll talk about acceleration.